Okay, so let's attack part B of this problem now, both methods by hand and calculator. The time required for our automotive center to do an oil change is still approximately normal. That means the curve looks like this, right? Has a mean, the center of that curve, the mean is 15 minutes, and the standard deviation is 3. The standard deviation is responsible, remember, for the spread of the distribution. We did A in a separate video. Part B, the center does not want to give the discount to more than 2% of its customers. How long should it make the time limit? The question is, where should we make this cutoff for the time so that the area or the probability that someone takes too long on that oil change and so they'll have to give them a discount is not any more than 2%. So we want that cutoff that cuts off 2% of the curve, or as a decimal 0.02. The question is, what is the time required? What should the x value be? Notice in contrast to the previous one, not a question of what percent, but how long, what time. Different question. We have the percentage, we want to know the x value. To do this, again, two methods. One, we'll do the method by hand. By hand, we first have to find the z-score that separates the 2%. 2% is 0.02. That means 0.02 of the stuff is to the right of the curve. Now in the table gives you the area to the left. So if we have 2% to the right, the area to the left of that is 98%, right? So over here, this is 98% until this cutoff region, or 0.98. So we want to find the z-score that has 0.98 to the left of it. So we're going to look in the body of the table for the value 0.98, and as close as we can get, and then we'll read the associated z-score. So let's see, we need 0.98. Get rid of those. Let's see if we can find 0.98. Here's 9803. 9808 is not as close. 9798 might be closer. So if you're trying to decide which one is closer to 0.98, you can take the difference of the two, 0.98 minus 0.9798 is 2e to the minus 4, or 0.0002 away, and then 0.98 minus 0.9803 gives us 3e to the minus 4, or 0.0003. So which one is smaller tells us which one is closer, and this 0.0002 is closer. That means 0.9798 is closer. So from here we want to read the z value from this value. So we go over here to read the first two digits, that's 2.0, and then go back up here to read the last digit, 5. That means that the z value is 2.05. That separates 2% to the right. Now that's a z-score, but we want an x value, so now we have to calculate the x value. The formula for x is that it's z times sigma plus mu, or z times the standard deviation plus the mean. The z is 2.05, the standard deviation was 3, the mean is 15. And this gives us a cutoff time of 2.05 times 3 plus 15 is 21.15 minutes. The calculator method is a little bit faster and definitely more accurate. Calculator. What we want now is not the probability, but the value, remember? So in the distribution menu, instead of doing the CDF, the normal CDF, which spits back probability, we would like to do number 3, the inverse normal. It will give back a value. So the inputs there are the area to the left. We calculated that right over here as 0.98. Then you need the mean of the distribution, which for this case is 15, and the standard deviation is 3. If you don't have the prompts, remember you just put them in the same order with a comma between them, so your input screen should look like this. Then press enter, and it will calculate the x value as 21.161246. Of course, you'll probably have to round to 1 or 2 decimal places, so 21.16 minutes. Not surprising, it's a little bit different, but not too far off, and certainly within the tolerance ranges of the problems.